What's up, Algebra 1 students? This is Lesson 31. So Lesson 31, our objective for today is how do you use rates, ratios, and proportions. So let's just kind of go over some definitions of what these things are. Let's first of all talk about what a ratio is. A ratio is a comparison of two numbers by division. Remember, there's a few different ways we can write that. We can kind of say like 2/3, or we could say 2 to 3, or we could say 2 to 3 using that colon there between them. Most of the time we look at this first one there as a ratio, but all of those are ratios there. A rate is simply a ratio with two different units. So maybe like 30 miles per 1 hour. A lot of times we just say this as 30 miles per hour, mph. Maybe 10 gallons per 2 minutes. And so notice these are still ratios, but they just have a unit associated with them that are two different units. So you can't say like 3 hours over 2 hours. That's not a rate because the units are the same. A proportion is an equation saying that two ratios are equal. So like maybe saying 3 over 2 is equal to x over 10. That's a proportion because there's two ratios that are equal to each other. And the last one there, we're going to slip in here is a unit rate. And a unit rate is a rate, like these ones right up here that we're talking about, with a denominator at the bottom of 1. So this right here, 30 miles per 1 hour, the denominator is 1. So this is a unit rate. So this is a unit rate. This is not a unit rate, but we could reduce it to be 1 by doing some division. So that's what a unit rate is. Remember, a unit is just like 1. So the denominator is 1. So this is kind of like example 1. Let's get started. What is a better buy? 10 bananas for $1.35 or 8 bananas for $1.20. So really we're trying to find out how much does it cost per banana. So notice what I just said, cost per banana. So we're going to write some ratios of cost over bananas. So this first one here we're going to do in blue. The cost is $1.35 and we have 10 bananas. So $1.35 over 10 is going to be 0.135. So this is dollars per bananas. So what this says is it is 13.5 cents per banana. In the red, again we're going to want cost per banana. So we're going to do $1.20 divided by the 8 bananas. This comes out to be, if you use a calculator or do your long division, either way, 0.15 per banana. Whatever. So notice this first one came out to be 13.5 cents. This one came out to be 15 cents. So which is the better buy? The better buy is 10 bananas for $1.35. Alright, this is like example 2. It says a car travels at 60 miles per hour. How many miles does it go in 1 minute? Now you might be able to figure this out mentally, but we're going to go through the process so we can do part B, which is a little bit harder to figure out mentally. So remember, 60 miles per hour means a rate of 60 miles per 1 hour. Now we're wanting to change this into miles per minute. So what we're going to do is we're going to multiply this by a 1, but we're going to multiply it by a special 1. We want to change hours into minutes. So remember that there are 60 minutes, and 1 hour. So since my hours right now are on the denominator, I'm going to want my hours to be on the numerator. And then on the denominator, now I'm going to put minutes. I want this to be 1, so we have to say there's 1 hour and 60 minutes. Alright, so this thing right here in that I just drew in the red is actually just 1, because 1 hour and 60 minutes are the same thing. So I'm multiplying it by 1, so it's not going to change its value, it's just going to change the way it looks. And then we're going to have my hours, and hours will reduce, right, to 1. Hours divided by hours is just 1. And so I'm going to have 60 miles times 1, which is going to give me 60 miles. And then I'm going to have 1 times 60 minutes, which is going to give me 60 minutes. So that's my units that I want, miles over minutes. But let's reduce that. 60 over 60 is just 1. So my answer is going to be 1 mile per minute. 1 mile per minute is going to be my answer. Or if you wanted to say 1 mile over 1 minute, either one of those would be fine. Okay, now let's look at part B here. It says, a hose sprays water at a rate of 10 gallons per minute. How many quarts per second is this? So let's first of all give the rate that they gave us here. It says 10 gallons per minute. So I have 10 gallons per 1 minute. And we're wanting to change from gallons into quarts. And we're wanting to change from minutes into seconds. So we're going to do the same process as in part A, but we're actually going to multiply by 2 different, what we call unit rates. So to change minutes into seconds, that's not too bad, because I remember that there are, I'm going to multiply this by 1. I want the minutes on top, and that means the seconds will be on the bottom. And in 1 minute, there are 60 seconds. Then to change the gallons into quarts, I'm going to want to multiply it by another 1. And this is going to be gallons on the bottom because the gallons over here are on top. And then I'm going to need the quarts on the numerator on the top. And then you can look that up in the back of your book, or hopefully you remember there are 4 quarts in 1 gallon. So again, this is just a number 1, and this is just a number 1. So we're multiplying it by the number 1 several times. So let's see here. The minutes will reduce from here and here. The gallons will reduce from here and here. And so I'm going to have 10 times 1 times 4 quarts. So 10 times 4 is 40 quarts. Over on my denominator, I have 1 times 60 seconds times 1. So it's going to be 60 seconds. Now, of course, I want to try to reduce. Let's see, 20 goes into that top one 2 times. 20 goes in the bottom one 3 times. So my answer is going to be 2 quarts every 3 seconds. Or if we wanted to get this into a unit rate, right? Because it says how many quarts per second, meaning in 1 second. We want to change that 2/3 into a decimal. Now, if you remember 2/3, if you're going to go back to our thought bubble, we've done this before. 2 divided by 3 goes in that 0 times, so put a decimal. It goes into 26 times. You get 18, subtract You get 2, goes in 26 times, keeps going on forever. So this is equal to 0.6 repeating quarts per second. Quarts per second. Right. Like example 3, this says solve each proportion. And if you have learned this before, we have a cool, we call cross product. To solve a proportion, we can multiply across from each other. So we can say, we'll take this x times 4. It's going to be the same thing as 3 times 24. So that's what we call the cross product. Some people call this a butterfly method because this looks like a butterfly. So I will have 4 times x is going to equal to 3 times 24. Or 4x is equal to 72. Divide both sides by 4. And you'll get x is equal to 18. Okay, now this next one, you solve still the same way, but there's a little trick. Whenever you have two numbers, do you see, or two terms in this numerator here, you're going to want to write parentheses around that just to make sure that we don't make a mistake around that. And we're still going to solve using the cross product. So we're going to say 8 times 5 is going to equal to 30 times x plus 1. So we're going to say 8 times, sorry, I said 5 earlier, 15 is equal to 30 times x plus 1. And right there is where a lot of people make their mistake, is they forget to write the parentheses around that x plus 1, because it's 30 times all of that. So we have to use our distributive property to get each of those. So 8 times 15 is 120. On the right-hand side, I'll use that distributive property, so that'll be 30x plus 30. Then I'll continue on to solve, minus 30 from both sides. Now I'll end up with 90 is equal to 30x. The x by itself, I'll divide by 30. And that's going to give me x is equal to 3.